So, hello everyone. My name is Lenz and I'm going to talk about ECMAScript as an evolving language. First, a short introduction about me. I'm Lenz on Twitter, I'm Fry. On GitHub and everywhere else, I'm Franius. I work as a developer at Mayflower. I'm working in professional web development since, well, half of my life right now. I'm absolutely in love with the web, open source, Linux, and security. And after this talk, if you want to talk about any of that, come around, grab a beer, something. I'm just getting used to conference speaking. In fact, this is my first conference talk. So if I'm a bit nervous, bear with me. I guess it'll be fine. And now let's get started. The first thing, this talk is titled ECMAScript, and well, actually, most of the things I'm going to say are about JavaScript, and especially JavaScript in the browser. I know there was ActionScript, which was an implementation of ECMAScript, but Macromedia Flash is dead right now, so we don't really have to talk about that. And a lot of the things that happened with JavaScript or the ECMAScript specification actually started somewhere in the browser or with needs from the browser. So most of the things I'm going to say are JavaScript and browser today. I'm going to cover ECMAScript, and I'm going to talk a little bit about things that evolved in the W3C DOM living standard, because ECMAScript is the specification behind JavaScript. It's the bare language. It gives interfaces for, well, syntax and interfaces for bare data structure manipulation. On the other hand, a big part of the language JavaScript is the API you are given by the browser. And that's what the W3C DOM living standard is, at least partially about, especially things like DOM manipulation. We're going to start with a short history of ECMAScript. Some of you might remember the old days, starting around 95 until 2001, the first big browser war. Somewhere in that time period, Microsoft and Netscape decided, okay, we need a common standard for JavaScript, because Mozilla called it JavaScript. In Internet Explorer, I think it was called JScript. And it was a bit different between them, so they couldn't really agree on a name and called it ECMAScript. Nobody liked it, but that's the name of the standard we have today. That standard was released first in 97, and then there was ECMAScript 2 and ECMAScript 3 until 99. There's not so much difference, so that's just the beginning. And then people started talking about what this language really could be. And they had great ideas. There was a draft for ECMAScript 4 that they called Harmony, that had every cool feature in it, absolutely everything. Classes, something that we really needed were modules, static types, generators, iterators, destructuring, but it was never released. So it was just too much. We had, in fact, to wait until 2009 until ECMAScript 5 was released, which brought a few new features, but nothing too great. So we got strict mode, which was nice because, well, we had those bugs before. Now the browser really told us you shouldn't really do that, so that helped a little bit. We get things like getters and setters. JSON handling was very important, so that was in there. And yeah, not too much for about 10 years of waiting. And then we had to wait another 6 years until ECMAScript 6 was released. And ECMAScript 6 in big parts was what Harmony should have been. So we got classes, we got modules, we got iterators, we got the for-off loop that for most developers today replaced the for-in loop that was absolutely useless. We got generators, arrow functions, promises, and we got useful scoped bindings with let and const. After that, every year we got a new version of ECMAScript. Until today, we are at ES9. But if you talk to people, most people will just say, oh, that new JavaScript, ECMAScript 6, or in short, ES6. Nobody will know what you're talking about if you say, hey, let's talk about the cool new ES8 feature. Everybody will think it's ES6, and given the speed the development had before that, I think that's absolutely okay. So bear with me if I'm saying ES6 today. Actually, I might mean ES7, ES8, or ES9, because honestly, I really don't care. It's modern JavaScript. And if you're talking about modern JavaScript, it doesn't matter too much, as you will notice soon. If you talk about the browser side, the W3C standard, it's not so easy to find out what really happened when, so I just picked out some things that you might know. The most predominant thing that we really needed in browsers was the element query selector, so a method that you call with a CSS selector and you get all elements matching that selector as a child of the element you called it on. That actually was only implemented around 2009. So until that, every browser had its own way of doing maybe something like that, and it was quite the hassle and troublesome. Something else that's not that important, but also really nice, is element class list, because then we could actually add a class to an element or remove a class from an element without doing lots of string manipulation. And to add something really current and really new, that's the fetch API that allows you to do AJAX requests and to do it in the same way in every browser. Well, not in Internet Explorer, but you will notice a pattern here. Internet Explorer is not getting updated anymore except for security updates, but on the same page we have to live with Internet Explorer, and maybe we'll have to live with Internet Explorer for the next 25 or 50 years, because Microsoft has no real intention of removing it. They just don't add anything new, and they say to most people, hey, please, please, please use Edge. And I know my grandparents, and I actually know my parents too. When they start using something, they will never go away. So we'll have to live with Internet Explorer. As I said, everything of that was possible, but one browser you had solution A, another browser you had solution B. It wasn't really that much fun. So in the large gap between 1999, ECMAScript 3, and 2015, ECMAScript 6, we had to do something about this. And this is where libraries were born. And we have two really predominant types of libraries. One type of library to fill in for the shortcomings in the language, and one type of library for the shortcomings in the browser APIs. So for the browser APIs, most of you will have used jQuery at some time. jQuery actually was the birth of element query selector. And yeah, just about anything that came after that was jQuery. jQuery brought so many new things, so many great new things. There were, of course, other libraries for the same purpose. There was MooTools. And on the other side, we had shortcomings in the language itself. working with arrays was a hassle, working with objects in many parts was a hassle. So we had those utility libraries like underscore or lodash, but also jQuery and MooTool, who also had their utility functions, but at least for me, those never really felt right, because those were made more for DOM manipulation and fast DOM manipulation, although they also worked for, like, let's say, an array of strings, but you really didn't want to do that. So we had those libraries, and after we had those, as I said, the standards caught up, the browser started converging, and essentially, except for Internet Explorer, we wouldn't have a problem today. And for Internet Explorer, for every missing API, we can just add a polyfill, and, well, we're done. All our problems are solved. They lived happily ever after. I think this was the fastest talk with 11 minutes. Thank you, ladies and gentlemen. Our prince, princess, or any combination of them can ride on the unicorn to the rainbow. I lied. You can polyfill functionality. You can polyfill missing functions. You can polyfill an interface, but you cannot polyfill missing syntax. And we have missing syntax. Something like the for-off loop I already talked about is syntax. This would be a parsing error in an old browser. And we can't live without that. So there was a solution. It's not a very nice solution, but it's a very cool solution. We can transpile things. So we write modern JavaScript. We take it, we put it into a transpiler, which, like a compiler, would compile C to assembler. This transpiles ES6 or newer to ES5 or lower. And we get a big blob of unreadable code, but every browser can parse it. And if you really want to get fancy, you choose your targets. You say, OK, I transpile it for an old Internet Explorer, and I transpile another version that will run in every current evergreen browser. And then you have one 5 megabyte blob of code and one 200 kilobyte blob of code, and everybody is happy except for the Internet Explorer user with a slow connection. But let's face it, he's used to the web being the way he is experiencing it. Of course, you still have to add polyfills for old browser, but with transpiling and polyfills, you can start using a modern language. So, for example, we write this. This is an asynchronous function. So we are using async await here. And with a modern browser, actually, that's not really much of a problem, but Internet Explorer would stumble about this. So let's look at the transpiled code, which is this. This consists of two parts. Part one is a state machine. So, well, that's not too complicated. We have a method that starts somewhere, that's left at some time, and that then it enters from the outside again and executes the next batch of code. And the other part is some glue that does exactly this kind of orchestrating from the outside. So this kicks off the other method. And if you have 20 asynchronous methods, you have 20 state machines, but only one can of glue. So it's not that bad. And when we're at it, we have found a way to do all that. It runs in every browser. And, well, why should we stop here? Things suddenly get interesting. We can transpile almost everything. So let's see what's out there that can be transpiled. If you go back to the first slide where I told you about Harmony, there was one thing in Harmony that was actually missing in modern JavaScript, and that was types. So you can use transpiling to extend the language with a type system. One example would be TypeScript. Looks like this. essentially, the interface up there is TypeScript. Oh, I have a... Yep. Hold it, right? Okay. This is TypeScript. This class actually is ECMAScript 6, but those implement and those type definitions behind the colon, again, are TypeScript. So you can just strip out all the type information. You have valid ES6. You can either use that in a modern browser, or you can transpile it down to ES3 or something. There's another language that does the same thing. That's Flow. One thing is from Microsoft, the other is from Facebook. I guess you have to choose your poison, but both are okay. I personally prefer TypeScript, but if you really have to choose between the two of them, and you haven't started with one, don't look at the language and which language you like more, but look at which libraries you are using and which libraries have the better support for one or the other, because you have to write typings, you have to type out all the APIs, and for many libraries, all those typings are present in Flow or in TypeScript, but not in both. So you will save yourself a lot of work if you do that before deciding which way to go here. But of course, you don't just extend JavaScript, that's so boring. Let's do it with a completely different language. One of those completely different languages, and I'm just showing a few examples here, would be Clojure, which looks quite Lisp-like. This actually renders diff with some paragraphs and a span as a React component in the browser. If you're not writing React in Clojure, you can also write everything else in Clojure and just run it in the JVM or the Java virtual machine, so native code, or you just transpile it to JavaScript and do something like React in it. It's quite nice, but not my type of language, no. Another language would be ReasonML, and this again is something that's been pushed by Facebook right now. That's very predominant. That's essentially a OCaml dialect, so again, very functional programming. And for me, that looks usable. I still haven't had the time to play around with it, but that looks really nice. Other examples would be, for example, Elm, which is also a language that was written, well, not primarily, but to very well fit the React use case. And other languages would be CoffeeScript or PureScript, which I think looks a little more like Haskell. Going through all of that, well, yeah, this is nice for playing around, and I guess there are many companies that have already a big stack of functional programmers that like to write Haskell or OCaml or Clojure, and that are just going on the web wagon, and that's fine for them. But most of us, or many of us at least, are still JavaScript developers, so let's see how else we could enhance JavaScript by adding new syntax. And I guess many of you already have that new syntax, and that new syntax is called JSX. This is another way to write JavaScript. This may look like HTML, but it is not HTML. This is JavaScript. So if you transpile this down to normal JavaScript, let's just take a look at this part. We have the definition of a div with a property class name, which is a string card, and a bad indentation, and two children, which is a h1 and another paragraph. If we transpile that, we get this, which is a React element of the type div with the property class name, a string as a card, and two children, one child and two children. So I don't know about you, I like to write JSX instead of this. This is a great addition to my daily development life. And you don't have to use it with React. In the old days, this wouldn't have been react.createElement, but just H for HyperScript, and many other languages or libraries actually adopted this age. And well, my transpiler is just set to make it react. But you could use this type of writing with many other libraries. And then we're finally getting to the point of this talk. It's called the evolution of ECMAScript. And now we're going to talk about JS Next. JS Next essentially are features that are planned or discussed to be part of one of the next specifications of ECMAScript, but aren't in there yet. With the power of transpilation, of course, we can already use those today. It's just build your own adventure, pick your characters and go on your journey. So let's take a little look at the standardization process. The standardization process is done by the ECMA TC39, which is a committee that meets every few months to discuss all those proposals that came in and if they should advance or if they should still change things. The nice thing about the TC39 is they accept a lot of contributions on GitHub. Every standard has its own repository, or every proposal has its own repository. You can start an issue there, you can start a discussion there, and this is really alive. So if you would say, okay, I want this new operator, and if I write anywhere, I want to add 5 to every integer. Absolutely useful. I can absolutely understand that you would want that. Then you would document your problem that you always have to write +5, and your solution that you want to write you would discuss it with the community, which would be absolutely happy to see this, and then you would find a TC39 member. I have to add the TC39 is a group of companies. So I think with enough money, you could get your company in there too to discuss the future of JavaScript. And essentially, you would have to find a champion that says, "Oh yeah, so great! I really want that in the language." And then he would be a champion. He would say, "Okay, let's make a proposal." That proposal would be its own repository, but already inside the TC39 GitHub repository. Or organization, and then you go to those 4 stages of proposal, draft, candidate, and finished. So stage 1, 2, 3, and 4. The discussion before that is stage 0, and there are, if you look at their website or at their GitHub page, there are many level 0, many level 1, many level 2, many level 3. There's a lot of proposals, some of them useful, some of them clearly aren't. If you want to use a proposal today, you just go to the GitHub, you find an interesting proposal, and if you look at their way of standardization, you would want to find a stage 2 proposal, because most stage 2 proposals should have already an implementation for a transpiler plugin. And to find out what transpiler plugin that is, put it into your Babel configuration. Yes, Babel is currently, I think, the big transpiler to be used. So you just put it in there, and 10 seconds later you can use. Absolutely great. I've shown one of those examples implementations. So I just went to that page and looked around, and I saw, yes, there's a decorator proposal that's currently in stage 2. There's a long RFC attached to it, and actually this is an example from that RFC. This example also uses another feature that's not part of JavaScript yet. That's private class fields. So this proposal includes another proposal in the standardization. And well, we have class decorators, we have method decorators, We have property decorators, actually on a private property. So this is what the JavaScript you are writing could look today, just because you choose to. This is absolutely chaotic if you could just go around and pick your language for yourself. But on the other hand, this is what evolution is about. You just try things out, and if it survives, it's great. And if it doesn't survive, it's apparently not so great. And the great thing is you go out, you try it out, and if it sucks, you go on GitHub, open an issue, and discuss it with the person that wants to have this feature in the language. And this process is really alive. This process is absolutely great, especially for a language that big. I think this should be the process that every language really uses. Well, in the end, what does this mean for you as a developer? If you're developing in JavaScript and you haven't started using those new ES6 features, you really should catch up. There's no excuse like, oh, but I'm on a legacy application and it has to run an Internet Explorer anymore. You can't transpile that. And if you already caught up, that's great. Then I really suggest that you learn one of those typed dialects, because I know we should be writing tests, and I know some of us do write tests, but some of us also don't really write tests or don't have the time to write tests. And a statically typed language is a static test of your code. It's not a unit test, it's not an integration test, it's a few levels below that, but it's the first type of test you will have in your code, and just believe me, you will be very happy about that. That's absolutely great. And also, for some of you who don't like to really read documentation, if you have a typed language and you import an external library, and there are typings for that, poof, out of the box you have autocomplete for everything, and it tells you which type you have to use for which function. So maybe you can get away without reading documentation. I wouldn't recommend it, but that might be a use case for that. And if you've gone through learning ES6 and you're using TypeScript or Flow, then, well, just give those new proposals a try. Look at some stage 2 drafts. The pipeline operator looks very promising. TypeScript out of the box allows to use decorators. I don't really think the language JavaScript needs private fields. I think it's enough to define it in TypeScript while developing, but that's just my opinion. So just pick what you like. There's a lot out there, and I think you're going to go into a whole new world with that. Okay. Any questions? Yep.
Just a functional question. Can transpile service workers for your browsers?
Can I transpile service workers? Yes, absolutely. A service worker is just a JavaScript file like everything else. And there's no reason not to transpile a service worker to a low level of JavaScript and execute it there. The thing is, for a service worker, you need a browser API and not a part of the language. So while you could use any syntax that's not part of your browser within your service worker, if your browser itself doesn't support service workers, you're out of luck. That's that. You can't do that. But within that service worker, if it's working, just use whatever you want. And if you want to use an Elm or Clojure service worker, that's fine. Anything else? Okay, well then to the shameless plug part, we are hiring. So if you're interested in modern web development, we are in Munich, we are in Berlin, and we are in Würzburg, and we are currently here, so talk to me. Have a good day.